Hello, this is Brother Cromar from the Math Department, and this is part 2 of Lesson 17. And Lesson 17 is dealing with describing categorical data, proportions, and sampling distribution of a sample proportion. So for part 2, we'll be covering, which is in the red box, finding probability for distributions of sample proportions. Before we do that, I want to review what we did back in Lesson 1 because there's connections. Okay, so what I'd like to do is deal with the distribution of sample means. So for instance, the length of a human pregnancy from conception to birth is normally distributed with a mean of 266 days and a standard deviation of 16 days. Suppose a random sample of 30 pregnancies was measured. What is the mean, the standard deviation, and shape of the distribution of sample mean pregnancies based on a sample of 30? Well, down here, the mean of the means is equal to the population mean, which in this problem is equal to 266 days, as you see on the top. The standard deviation of the sample means is equal to the standard deviation of the population divided by the square root of the sample size. And in this problem, it's 16 divided by the square root of 30, which is equal to 2.92 days. And the shape of this distribution of sample means is normal since the parent population is already normal. We have a sample size of 30, but since the parent population is already normal, the distribution of sample means is also normal. So then what we did, going back to Unit 1, is that we can find area under a distribution of sample means. So length of human pregnancy from conception to birth is normally distributed with a mean of 266 days and a standard deviation of 16 days. What is the probability that a random sample of 30 pregnancies have a mean pregnancy period less than 260 days? So we need to get the z-score for 260 days, which is right down here. So we take the 260 minus the mean, population mean, which is 266 days, which is the mean of the means, divided by the square root of the distribution of sample means, which is 16, divided by the square root of 30, and that's all down here, and we get a z-score of negative 2.050. So then to get the probability, we go to the applet here, and here's a representation of the applet. We put in on the bottom left. I just have it marked here, but on the bottom left of what's in the box here, it's negative 2.050. And we shade to the left, so this blue area that's to the left of negative 2.050, we shade because we're looking for the probability that it's less than 260 days, so we shade to the left. And then if you look at the area box here, on the bottom right, the area box at the top of the normal distribution curve, it's 0.0202. So there's a 2% probability that a random sample of 30 pregnancies will have a mean pregnancy period less than 260 days. Okay, so now what I want to do is talk about sampling distributions of proportions. So a nationwide survey indicated about 80% of college students, so that's our population proportion, so students with cell phones send and receive text messages with their phones. So suppose a simple random sample of 200 college students with cell phones is obtained. What is the mean, the standard deviation, and shape of the distribution of sample proportions based on a sample of 200 students? Well, the mean of all the sample proportions is equal to the population proportion, where in this problem it's equal to 80%, or 0.80, depending on if you put it in decimal form or percentage form. The standard deviation of the sample proportions is equal to the square root of p, which is a population proportion, times 1 minus p divided by n, and that's all square rooted. And if we solve for it here with the information above, which is 0.8 being the population proportion, 200 is our sample size, we get a standard deviation of 0.028 or 2.8%. Okay, the shape of this distribution is normal. If you look at the online textbook, it's NP is greater than 10, meaning the sample size times our population proportion is greater than or equal to 10. So you can just take 200 times 0.8, and that's well beyond 10. And then n times 1 minus p, that's also greater than 10. Those are the two requirements. So since those two requirements are met, we can assume that the shape of this sampling distribution, or the distribution of sample proportions, is normal. Okay, so then what we can also do is we can find area under the sampling distribution curve. So a nationwide study, I'll go back to the top here, the nationwide study indicated about 80% of college students with cell phones send and receive text messages with their phones. What's the probability that 86% or less college students in the sample of 200 send and receive text messages with their cell phones? So what we're going to do is, first of all, we're going to this 86%, we're going to convert this into a z-score. So what we'll do is we'll take this is representing a possible sample proportion. We're looking for 86% or less. So we're going to take the 86 or 0.86, so we're going to do all this in decimal form for the z-score, minus 0.8, which is our population proportion, and then we divide it by the standard deviation of our sample proportion, which is the square root of 0.8 times 1 minus 0.8 divided by 200, and then we get a z-score of 2.12. Okay, so referring to the formula that's listed here on the right side here. So we take this 2.12 and we put it, if you go down here in the bottom right in this box, that we put in 2.12 on the bottom right of the box. But it's asking for less college students, so instead of shading to the right, we shade to the left. So we have a big area to shade, and so if we look at the very top under right next to area, we see a number which is 0.9830. So there's about so the probability that 86% or less in our survey send and receive text messages is about 98% or 0.9830. Okay, so now what we're going to do is that we're going to do another problem here, where this was from the online textbook. A true proportion of people who support a particular political candidate is P, which is a population proportion of 0.48. Okay. If n is equal to 1,041 people are surveyed, what are the mean, the standard deviation, and shape of the distribution of sample proportions? So stop the video and see if you can figure this out. Okay, so the mean is equal to the population proportion, which is 0.48 or 48%. The standard deviation is the square root of p times 1 minus p divided by n, which is equal to, and then we put in 0.48 for p and 1,041 for n, and if we solve for that, we get 0.015 or 1.5%. So the shape is normal if we take n times p. That's going to be that's going to be close to 500. That's going to be well beyond 10. If we take n times 1 minus p, same deal. That's going to be beyond 10. So we can assume the shape is normal. So then our last slide is, so going back to the problem, and if the true proportion of people who support a particular candidate is 0.48, and if n is equal to 1,041 people, what is the probability that the results of the survey will suggest that the candidate will win the re-election or win the election? So first, what I want you to do is stop the video, and I want you to calculate the z-score first, and then find the area under the curve. Okay. Now the first step is to calculate the z-score. So if we calculate the z-score, we put in. So notice here I put in 0.5. What's the probability? Is if you go back to the problem and at the second line near the top, what is the probability that the result of the survey will suggest that the candidate will win the election? Okay. So all it takes is a simple majority, something above 50%. So that's why I put in on the z-score 0.5. And so we take 0.5 minus our population proportion, which is 0.48, and then we divide it by the standard deviation of the distribution of sample proportions, which is over here, which is the formula if you see on the right here. We're just plugging in 0.48 for P and 1,051 for N. And we get a z-score of 1.292. And then the next step is go to the applet to get our area. Now I already got the answer up here, but what we do is that we take in if you look at the applet on the bottom right, you put in 1.292 on the box on the bottom right of this applet. You shade to the right because we're looking for greater than 50%, and a majority, and so when we shade the area, we would get an area of 0.0982. Okay, and that concludes the video. If you have any questions, please speak to your instructor.